Thank you very much for coming to my presentation. I'm sorry we are a little bit late, but now everything is working, so we're all good. Thank you. Today we're going to be talking about machine learning. I know that machine learning is gotten to be quite the thing. I know that in most companies there are now people that are generally doing at least something in machine learning, if not doing it now, if they're talking about it. I saw one of the sponsors who actually has a advertisement that says that they're doing data science as a service. So it's obviously a really hot thing, and I know a lot of people are interested in learning more about it. Well, one tool that I think is really a good one to learn more about it is Azure Machine Learning. It is the only, and I mean only, Microsoft Azure product that is absolutely 100% free. So you can learn and it won't cost you, and it's a really good tool for doing that. So I'm going to go ahead and introduce you to it if you haven't done anything with it. How many people here are doing something now with machine learning at all? Yes, right audience. Great. So thanks to the sponsors, I think it was TIDK, the one that was doing data science as a service. So it's obviously getting to be something that's more and more popular, and everybody, I think, is going to need to do that to continue doing their work in data, because everyone's going to require it. All right, so agenda, oops, that's the wrong slide. So we'll just skip that one. For those of you who don't, forgot the slide a minute ago, my name is Ginger Grant. I am on Twitter way too much at Desert Isle SQL. I blog quite a bit at desertisleSQL.com. I am also, in addition to writing my blog, I'm also an author. I wrote the Azure Machine Learning Services Exam Book 774. So if you are interested at all in that certification, I can tell you more about it. And it is on Azure Machine Learning. And I'm also a Microsoft certified trainer. All right, so with data science or machine learning, and I use the words interchangeably because I'm not going to fight that fight. And I think that they conceptually do the same things. With both of them, you are doing manipulation in data. But really for looking with machine learning, I was at a client not too long ago, and they obviously thought that I could work magic. And, you know, this is a presenter, it's not a magic wand. I can't do I can't do things with data that the data won't let me do. And machine learning and data science cannot answer every question. It really is kind of limited in what it can do. So what it can do, though, is see if there's a relationship with your data. So if you've got a giant pile of data and you want to know how things relate together, it can do that. A couple of examples might be that they now use a lot of this kind of analysis when looking at where to align things in grocery stores. So they analyze the sales tickets, and they determine that if it is a guy buying diapers, chances are he's going to buy beer. So they now put the beer and diapers together in stores, because a lot of guys say, you know, get the call, honey, can you buy, you know, some diapers on your way home? And they put the beer right next to it, and that has increased beer sales. So a lot of what you see about where items are together in stores has everything to do with finding relationships within the data, and then they put the data that way. So that's one thing that it can definitely do. And some of those relationships are kind of weird. Is there something wrong? Anomaly detection is something that most people are pretty familiar with. I don't know how it works here, but I can tell you that in America, periodically I've gotten calls from my credit card company that said, did you just make a transaction and reverse it over at the Quick Trip on 27th? And I'm like, no. They're like, yeah, we didn't think that was you. We just canceled your card. Don't use it. We think your card has been stolen. That kind of analysis is called anomaly detection, a very common thing that's used for machine learning. The credit card companies do it for real-time streaming. I've also done it, or tried to do it anyway, for companies when they've got machinery to determine what the data looks like right before it's supposed to blow up. That's the kind of thing that you can do, and question that you can answer with machine learning. And you can also kind of predict what will happen. Kinda. Because this is not perfect. The only exact science is, of course, hindsight. But what you can do is look at a number of different algorithms that try to predict how the data is going to be based on how the data is in the past. And there's a number of different models with this. Believe it or not, this is something that is a big time add-on in Excel. I do a lot of Power BI, so I end up learning more about Excel than I'm interested in. But because there are a number of different algorithms that you can use, and depending on your data, depends on which algorithm would be appropriate. For example, I know that that H&M is going to be their sales are going to increase in November. Wow, I'm a psychic, because I know that right around Christmas everyone goes out and buys stuff. So if there's a seasonality component to your data, you would use a different algorithm than if you're looking at sales numbers for a product that doesn't particularly change over time, like perhaps automobile sales don't have a real seasonal component to them. So different data requires different algorithms, and these different algorithms will help you predict what's happening. Just for an example, there are a number of these that exist in Power BI. If you look at Power BI, there is a time series component that you can do that will show you, that will apply an algorithm to your data and do some machine learning, and you can pick the different algorithms that it has, and it has four, to see which one might be able to predict, what your data is going to be like in the future. And what's great about doing prediction is you can test it by looking in the past and see how it predicted last year's data. And if it did a good job with that, then it probably is doing a good job going forward. But you can also look at how things are organized, what things tend to go together. I did some work for a client, and for insurance, and they were convinced that if the insurance that somebody bought had a lot of extensions on it, for example, if you buy a renter's policy, they don't necessarily cover, like Camel's huge collection of photography equipment, because, that's over and above what the normal person would have. So he would have to get an insurance writer so that they would cover all of his, photographic equipment, so he can do all of his YouTube stuff. And they thought that if somebody had that kind of insurance, they would be less likely to drop it, rather than me, who I don't have any of that, so I just have standard insurance. And so you can look to see if those relationships exist. By the way, it didn't matter. But that's a kind of an organizational question that you can answer. And then you can look at what you can do next, because this gets into doing predictions so that you can start determining what would be a good solution based on what your data is telling you. So these are the things that you can do with data science. And so the kinds of things that you can think about what you can do. But of course, your ability to do any and all of these things depends on your data. So when you're talking about machine learning, what is it? It's developing algorithms for making predictions about data. You are actually, the reason they call it machine learning is you're actually teaching it how the data is organized, and then it guesses based on data that it doesn't know about. It is a branch of artificial intelligence. It's really not new. They have been working on a lot of machine learning components since the 50s. What is new, and why you're seeing it more and more and more, is we've got such great ability to do computing power. With things like Azure Databricks, you can throw all the resources that you can possibly want to at your data to determine an answer. And you weren't able to do this before, so nobody wanted to wait like 8 months to be able to process the data, so that kind of stalled out. But a lot of the algorithms that are being used now are algorithms that were developed a number of years ago. It's basically classifying and organizing your data, and then sorting it out and making it into a response. And then you can do things like, robots. So looking at predictive analysis is one of the more common types of machine learning. The one that we are not going to talk about is heuristical or rules-based. And oh, by the way, that's what you use with electric cars, because what they're trying to do is continually look at a bunch of rules and see if the rules apply in a given situation, which, unless you're doing machinery, is not what you would kind of analysis that you would do. Predictive analysis is very common, and it's basically statistically using probability to see if something is going to happen. Most people actually are very familiar with predictive analysis. Anybody who's ever done any sports betting, because that's what predictive analysis is. So if you want to look at, or I might add Eurovision, since I noticed that just got started. So if you want to see what are the predictive odds that Israel's going to win again, that's predictive analysis. So it's basically using statistics to see, what kind of things have happened in the past and what's the likelihood of that happening in the future. My money's not on Israel. I don't know who's going to win, but I doubt it's going to be them. They can use, it's using statistics. A lot of people ask me, well, do you need to have a master's in statistics to be able to do machine learning? And the answer to that is no. People who have masters in statistics would tell you that I'm wrong, but I know that it is something that you can teach yourself. And what's important to understand is the concepts, because the computer's the one doing the math for you. So if you have a really good ability to understand different and advanced concepts and the ways that they can be applied, you don't necessarily have to take 2 years off of work and study statistics to be able to understand how it works. And this is only, so with predictive analysis is only one of the types possible, but it's one of the more common ones and one of the ones that people are most often getting into. The whole purpose of doing this kind of analysis is because over time people have determined that if you make decisions based on data, then your decisions that you make are going to be more accurate. And result in better profitability. One study that was done a number of years ago determined that in the U.S., which is where they did the study, that the stock market price went up on the average about 7% when the major decisions were all made using data. So it's obviously gotten to be really popular because it makes people money. And now that everybody is storing data, because data storage is really cheap, unless you talk to your administrator and you want a couple more gigs and they act like that's the end of the world. But having all of this data means you can analyze it and find patterns over time. If you don't use that, people generally use the Hippo method. Anybody here heard of that? You haven't heard of it, but I guarantee you've seen it, because that stands for highest paid person's opinion. And frankly, if you don't have data, it's the guy in charge who generally makes that decision. But it's not a, statistically speaking, very good way of doing it. So data scientists spend most of their time on data preparation. I know that a lot of people think machine learning, and they think, I need to know all the algorithms, I need to know all this math. But what you really need to know is how to manipulate data. It's the most important part of doing machine learning, because it's what you do spending all of your time. And since this is a SQL conference, I'm willing to bet that everybody here knows how to do that already, or is pretty far down the road in it, because you spend your time doing data analysis to determine if the analysis is even possible. For example, I was doing some work for an oil company in Houston, and they wanted me to do anomaly detection. So they wanted me to find out if there was an error for their pumping equipment, because when they pump oil, generally speaking, the oil is very far away from where anybody lives. And they have to send somebody all the way out there with all the parts that they need to be able to fix it so it can come back up and working again. So they have all of these sensors on all that equipment out in the middle of nowhere so that you can determine whether or not you need to do a repair. And so I was looking at the data, and I said, you only have 2 reports a day. And they're like, well, we have more than that. I'm like, well, I see 2 reports a day. And so they determined that there was some kind of aggregation going on by their vendor. And then I asked them, well, can you show me where in your data something actually crashed? And they said, well, we don't want anything to crash, because when it crashes, we'll lose a lot of money. So before anything's going to break, we just fix everything, and then we don't have to worry about it. Well, guess what? I can't do anything there, because you don't have data that is in the small enough granularity so I can see what happens right before it's going to blow up. And if it never blows up, how the heck am I supposed to know what that looks like? So I couldn't do it for them because of their data, which is unfortunate, because that would have been a great thing for me to do. But I had to tell them, looking at the data, it was like 2 hours. I can't do what you want me to do. And that is a lot of times what you have to look at in machine learning, because what people want just isn't possible because they don't have the data for it. Another thing that I did some work for a bank, and they wanted to do a lot of analysis of their customers to determine which customers would likely to buy certain products. But their data was relatively inconclusive. And I told them to be able to better be able to predict which customers would buy which products. I would need a lot more to know a lot more about their customers than who deposited a check last Friday. That wasn't going to do it for me. They would need to have more definitive information about the customer, or because the way their data was, I wasn't be able to predict anything. But I did only find that out after about 4 weeks of trying, so sometimes you just figure that out over time, and sometimes you can see it up front. But if you look at this particular chart, you see most of the time you spent on doing cleaning and training data, and then very small part of it is actually refining your algorithms and looking that over. So with machine learning concepts, what you need to have to be able to make this work is you need a training set of data, and then you need to put algorithms against it. And then you have a hypothesis, what are you trying to prove here? Are you trying to see if certain things relate? Are you trying to see if there's anomaly? If you're trying to, to see a pattern in the data, and then basically see if your algorithm is able to predict that for you, or a series of algorithms for that. So in Azure Machine Learning, what they have done is they have classified these different types of model into 4 different groups. And this is very common with machine learning to the 4 groups that you would need to use for your algorithms. So it's not specific to machine learning. Anomaly detection would be error. Classification would be determining if something is likely to happen. For example, is England likely to win the World Cup? That's classification. It's a Boolean, simple yes/no answer. Clustering, what groups of people act alike? And then regression is where you are doing predictive analysis. So basically what you're looking to do is using gambling, which is applied data science. So you're looking for probability, whether or not things are correlative, and their significance. I know that there was an octopus that was doing World Cup predictions, and he was apparently pretty good, but you cannot necessarily correlate octopuses and World Cup predictions, because some things just are happenstance. For example, there was a study done in the United States that determined that if parents of newborn children, if there is a light on in the baby's room, that child is more likely to need glasses. And someone said, oh, and everyone went and turned off the lights in the baby's room. Well, somebody else looked at that study and said, well, the people who are most likely to have a light on in the baby's room are the people who can't see well to begin with, the parents. So if the parents can't see well, it's pretty obvious that the kid's not going to see well, and the light had nothing to do with it. So that's a kind of correlative analysis that you need to know on your data as well to see if that you're drawing the right conclusions. So all these people were like wandering around the dark thinking they were going to save their kids' eyes, and it was going to make no difference, just meant the parents had bad eyes to begin with. So that's the kind of thing that you need to analyze with your data as well, and looking at the significance of the difference. How much of a difference is it over time? So there's a lot of terms that that are thrown out there with machine learning. Linear regression, which is looking at the relationships things. Forecasting, we just talked about correlation. Decision forests, which are a lot like sports brackets, to see if 2 decisions, which one you're going to make. Discretization, looking at how you need to have the data organized to be able to do certain kinds of analysis. There are certain kinds of algorithms that require you to normalize your data so that the highest level is 1 and the lowest level is -1. So if you have like housing sales data, you need to modify your data so that the highest, if you have $1 million house, that would be 1. If you have a $10,000 house, that might be -1. And normalize your data between the two, which is another step you may need to do. And then of course, naive Bayes, which is basically a very common algorithm that's used for predicting based on the elements that you can see. So we're going to be talking about a couple of them. Linear regression helps you do the relationship between 2 or more objects. And you're looking for patterns to see if things do in parallel. I mean, this particular example is the amount of frozen yogurt versus high temperature. I can tell you that I spent some time walking around Poland, and I will say, since it's freezing outside, gosh, you guys think there's no spring here. This is like winter to me. And guess what? Nobody's buying ice cream. I'd be willing to bet if it ever warms up here, people will buy ice cream. See, this is the kind of thing that this chart would represent. And that's just linear regression. So you're looking for things that run in parallel. And then there's different types of forecasts that we talked about earlier. This is a graph kind of showing where the forecasts are predicting. And obviously the one that's best is the blue line, and the ones that the gray are different shades of gray are using different algorithms. So depending on your data determines what kind of algorithm that you would need for that. And then you got to look at correlation. I don't know if you guys do Sesame Street over here, but there's this little song goes, one of these things are not like the other. And that's the kind of thing that you need to look for to see if things are actually related and determine how they relate, if it's logical. And this is used in a lot of different kinds of analysis. And this is an example of a decision forest. So this is in the States, there's this, the national gambling pastime is in March, and it's for college basketball. And it starts out with 128 teams, and obviously one person wins. And this is just an example bracket from that. And this is a perfect example of a decision forest. So actually, this is a decision tree. A tree can have multiple forests, so you can have a number of these that are used in machine learning. And what this does is it teaches it how to learn. You're like, okay, if this situation, then this one wins. This is actually used a lot. I was reading an article about self-driving vehicles, and they were trying to determine what the vehicle should do. And apparently there's something wrong with the software because it's deciding in the situation where the light is green and somebody steps in front of it that they should keep on going green because the light's green and they should be going. Of course, those of us who might be jaywalking in front of the car have a different opinion, but that's why we don't have machine learning cars right now. But that again, that's a decision. That's the kind of decision that's made in an algorithm. So discretization, this is actually another process for binning, for modifying your data. It's commonly called binning because it's easier for algorithms to classify 10 things versus 10 million things. So if you put things into bins, little buckets, it might be easier to do the analysis for. And that's commonly displayed as a histogram, which is what you see here. So this is just grouping things, from 0 to 499. And then in groups of 50 to be able to see how they work together, because that's something that will help your algorithms. So once you're doing this kind of analysis, then you want to know, all right, that's great now. Yay, I've completed this algorithm. Is this right? Am I done anything? Is it useful? Well, different algorithms have different methods of determining whether or not they're correct. We're going to initially look at a binary analysis. And a binary analysis is determining whether or not something is or is not. So what we're going to look at is we're going to look at census data, and we're going to say, is this person going to make $50,000 or more? Yes, no. And for that data, we're going to try to predict whether or not the data is correct by looking at where we have answers. So where we don't have answers, then we can guess. And that's the kind of thing that you might want to do for doing market analysis, because perhaps you know how your customers act, so you're guessing that people who aren't your customers would act the same way in a given situation. For this kind of analysis, the most important thing to do is to be able to guess better than a coin toss. Because if you can't guess any more better than a coin going, whether or not it's heads or tails or not, then your analysis is worthless. Because you need to be able to predict better than 50%. Better than 50% is that line going down. That is the 50% line. And the area above that is called the UAC, so it's area under the rock. And the rock is the receiver operator characteristic, which is the green line on the end, and that's what the data actually did. So what we're looking for is a really big curve on the other side of that diagonal line. When you're using test data, everything generally goes over the other line. Unfortunately, in the real world, when I've done this kind of analysis, I had a whole bunch that were on the other side of the line, which meant that I needed to do more work. And you measure the volume, and the better that gap, then the more likely your algorithm is correctly predicting things. So picking the right model is kind of hard, because this gets into knowing what the algorithms are. And this is why Azure Machine Learning is a good tool for starting this out, because it shows some for you. and you can get familiar with a set of very common algorithms, understand what they do, and then start branching out from there and learning other ones. And we'll look at, so there's a whole bunch of these. You can look to see which one gives you the desired outcome. You can look at the math, and you can do what I call the spaghetti test, which is just throw a whole bunch of things against a wall and see which one sticks. Over time, that's not the most efficient way, but it can help you learn which model would be the most effective. So the steps for machine learning that you need to do, it doesn't matter if you're doing this in Azure Machine Learning or any other tool. The first step you do is clean the data to see what you got. See if your data is good, bad. When you've got data, generally speaking, you can't have nulls because you can't evaluate nothing. There are exceptions to that. I did do some analysis for a company that makes standardized tests. And there are people who have memories, so that they pictographic memory, so that they can look at something and they can remember it later. And so they take a test and they do the test until their brain is full, and then they leave. And then they go and write it all out and then sell it to somebody else. So in that case, in fact, there's a lot of nulls, matters. Because if there's a lot of nulls, then it's probably that cheater guy that was taking the test to begin with. But most of the time, it's just like a one-off null, and that won't help you at all, so you have to drop it. So it's very important that your data is clean and standardized. So you want to then, once your data is clean, you want to pick a model and see what kind of analysis you're going to be doing. You know, in our case, we're going to be doing binary analysis. We're going to pick an algorithm and then score it, and then we're going to look at that ROC curve to determine the success, and if our algorithm's terrible, then we'll do that steps multiple times. So while you don't have to use Azure Machine Learning to do these steps, I really think it's a great tool because, well, it's free, and it's a great place to learn the steps so that later on, if where you work, they're like, yeah, can you do this in Python? You'll understand the concepts so that you can translate mentally what you have to do to write it in Python versus do it in Azure Machine Learning, because the steps are exactly the same. Although this is a GUI, so it's easier to learn. Interesting story about Azure Machine Learning. I will say that Microsoft needs some new marketing people. I told them this when we were in Redmond, because they are now calling everything Azure Machine Learning. There's like 3 different products now called Azure Machine Learning. But what I'm talking about, they refer to in their literature is Azure Machine Learning Studio. So it's important to specify that, because if you don't specify Studio, then you will find the Azure Machine Learning product that will allow you to monitor your existing Azure Machine Learning modules. And there's another one that they also call Azure. Oh yeah, and they also call Azure Machine Learning the .NET library that you can now include in C#. And that's also called Azure Machine Learning because they ran out of fun names. But this product, interestingly enough, was something that Microsoft was looking at getting rid of. And they kind of tossed that around for about 3 months last year. And everyone really said, no, 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 because they really, really liked the tool. And they were really surprised because they thought that people wanted a different tool. So they created this tool called Azure Machine Learning Workbench. And that's gone now, by the way. It's dead. It doesn't exist as a product anymore. But this tool survived because it is a very good tool, that, especially if you're starting to learn it. So with that, I'm going to go ahead and do a demo on it. I get you introduced. Oh, what? So to get it, I will say that you don't even have to have a credit card for this. Let me go back so I can show you exactly where I ended up when I got here. So you need, if you want to do what I'm doing now, you can go to studio@azureml.net. And like I said, totally free. They're not going to ask you for a credit card. All you need to do is to have a Microsoft ID. If you don't have a Microsoft ID, just go to outlook.com and create one. Hey, everybody needs more than one email address, right? So I'm going to go ahead and sign in. Okay. Where do you hide the @ sign? Oh. Polish keyboard. That's not standard. No. That's okay. And the American one is above the 2. It's supposed to be the English one. Okay, I still can't type. Ah. Sure. All right, so now I'm logging in. And what you get on the left are you get projects, experiments, web services, notebooks, data sets, trained models, and settings. As far as data goes, you can use data that comes from anywhere. For example, if you want to access the data on SQL Server, you can. What you need to do in order to make that happen is you need to install a machine learning gateway. 2 little caveats about that. You cannot install that gateway on any machine that has a Power BI gateway on it already, because those 2 teams don't like each other and they can't get together, and so they don't work together. So you cannot install them on the same machine. The other thing, although I told you you can do everything for free, yeah, that one you pay for. So you do have to have a paid license if you want to access data from SQL Server directly. Now, so if you are in learning mode, what you can do is you can just copy it to somewhere else. Like if you just want to extract it to a CSV, then you can just upload that CSV. So that you can do it on a free account. No, I'm not lying to you. One thing that's really great about this particular environment is there's a lot of places to look at code. If you open yours up, you will have nothing in there, and you'll be like, oh, that's great. What am I supposed to do now? You can look at this gallery. And this gallery has a lot of really great samples that you can look at to try to learn about Power BI. So Power BI, machine learning. So if I want to learn binary, so there's a number of different samples here. So I could look at, and most of these are done by Microsoft, a binary thing of student performance. I can open this in Studio, and this gives me a completely working model that I can take a look at and see how it all ticks. And it's going to ask me a region. So I'm just going to say OK. And it'll open up here in a minute. And this one's kind of, OK. It's upgrading my experiment. Fine. This is kind of a very large experiment. Probably wouldn't want to do this straight off. But this is an example of something that you can look at that's very complicated, and you can run this yourself. So you can also, I assume you actually want to see what I'm talking about here. So you can, I'm just pressing the plus button. So it's showing you what the steps that it's doing. So it's importing data, and then selecting some columns, cleaning missing data, running some R, and doing a lot of other steps. So just an example, obviously kind of complicated example, but we'll look at something that's a little bit easier to deal with first off. So what I want to do is look at an example that I have prepared for this session and show you how these components work. So if your first step is to get data in here, you need to add the data into the environment. You can directly connect to any Azure storage, so you could connect to blob storage or an Azure SQL database without having to do anything. But if I wanted to import some data to here, I would just click on the new button, and I would go to Dataset, from local file, and this would allow me to upload any data that I wanted to into my environment that I could use for testing. The limits on the free account are, I think it's 250 gig. But I will say that for UI analysis, you cannot use very large data files because it can't handle it. This is meant to be a testing environment. And I had a client actually, and the reason that I got them is they're like, well, we tried using Azure Machine Learning and it didn't work. I'm like, oh, really? No. I said, well, what did you use for data? Oh, we put this like 2 terabyte file up there and it didn't work. Well, this would have saved them 6 weeks of consulting work, but I wasn't about to tell them this. You can't load that much data up there, it won't process. So if you're doing your analysis, keep the amount of data to probably 10 gig for your testing would be all that you'd want to do. Now I can run a 3 terabyte file if I wanted to, but I can't do testing on it within the UI because the UI will blow up. And that will not change if you bid a paid account either. Because that's what they said too. They're like, well, we were doing free because we thought we could get away with that. So we bought a standard account and, we're about paying for it and it's not working. I'm like, yeah, it's because it doesn't handle that much data. Oops. But so for your testing purposes, you don't need to have that much data. When you are done, you can run as much data as you want to through it. So I'm going to show you the steps for that. So this would be where I would upload a file. And if I wanted to upload a file, I could then go into my data sets and pick it, which is what I did here. And I picked this adult census income binary data set. So let's take a look at this data set. It provides a really nice visual demonstration of the data that's contained within it. You can see that I've got 32,561 rows and 15 columns. And I can see a picture of what the columns look like. And it tells me if it's numeric or not, which is important because if I think something is numeric and I change it, then I will have some problems. So, and it also tells me what my unique values are and whether or not I'm missing anything. Because if I'm missing data, then I have to figure out what I'm going to do with it because I can't, for this data set, having data that I can't parse is not going to be very helpful. And my result in my data set is here, and this is income. And this is if somebody is making greater than or less than $50,000. So I'm going to use this data to predict that. But I can tell you that there's some data that I'm not going to use because it's not terribly helpful. So I'm going to get rid of it. For example, I've got duplicate data here because I've got education and then I've got the number of years of education. I don't need both. So I'm just going to not use this. Also, funnel weight, I don't know what that is, but it doesn't seem to be anything that's particularly useful, so I'm going to get rid of that as well. So but for this one, generally speaking, what I decided to do is leave those in there just to see if it would make a difference. So I've got a data set. It's reasonably clean. And I've decided that my first step is I'm going to do some tuning. So what I'm going to do is I'm going to tune my income just to make sure that it's standardized. And then I'm going to score it, and then I'm going to evaluate my model. So I'm going to go ahead and do that. And when I do that, in terms of what I wanted to pick for an algorithm, what I did is I looked for binary classifications, and I picked one. So I'm going to go to binary. I never remember where this stuff is because I can just look here. So I can see that these are my binary algorithms under classification. And so I've selected the 2-class support vector machine to see if I can use that to analyze my data. So I'm going to go ahead and run that. And it's running now. And because this is an Azure demo, I have no idea how long this is going to take. So if this takes a long time, I do have this already running. Already completed, so we can look at that completed version, but this didn't take very long. So I'm going to go ahead and visualize the results. And when I do, we'll see the area, we'll see this is my diagonal line, and this is my area as my receiver operator characteristics or ROC curve. And you can see this is a great algorithm because it was very well able to predict whether or not somebody was making greater than less than $50,000. So I have gotten a very good result. I have my results here. It tells me that it's very accurate, pretty good precision, and recall my F1 score. So this is what this is doing. This is analyzing the numbers here. This is what's called a confusion matrix, and it's telling me, it's analyzing my data to see, okay, you said that you guessed that this many were true, and this is how many that was the case. This is how many false negatives there are because it was really true and it guessed false. This is how many false positives, and this is true negative. And these numbers here are representing the importance of those scores. So this has got 80, so this is true 84% of the time. So it's relatively a very good model. And it's, if I look at the scoring here, I can visualize, I can take a look and see what it said the results were versus what they actually were. So if I do here, I can see that it said what it said versus what I said to compare how well I was at guessing. And so this is a prediction. So this is predicting that it's above 50%, and it actually is. So I'm doing pretty good with my predictions here. So in this instance, obviously I have the answers, and I'm seeing how well my algorithm is going to predict what's actually there so that I can do the same data set where it's not true. There's a really good example of this on Kaggle, which is a website where people look at a lot of machine learning algorithms, and they did the same kind of analysis with figuring out pictures of cats and dogs. And in their example, they got so that they were better able to predict which picture was a cat and which picture was a dog than a human would. Humans scored 94% and the computer scored 96 because it learned over time. And there's some really goofy looking cats and dogs out there. I looked at that data. I'm like, wow. But how they did it is first they ran it with the labels and then they ran it without, which is what you would want to do with this data. Because lots of the times you don't have the answers. And so you're using this to predict what the answers would be. So if I have data and I have a model and I want to create this and I want to actually run this in production and use this, my next step is I need to create a web service. And then I can take that web service and I can call it from anything. I can call it from a ADF, Azure Data Factory. I could call it, say, within a web page or even Excel, which is what I'm going to show you how to do. So I can go ahead and create a predictive web service. Again, this would be very similar to what you would do if you were doing these steps yourself. So if I'm going to go ahead and say that I want to create a predictive web service, what it's going to do is it modifies my data slightly. So what it's done here is it's created it's taken my data out and says this is just input. And that's why I have a web service input module instead. And then it's taken my algorithm and it's making a module out of it. So it compiled my code for me. And then it gave me a score and then my output. So it did these steps for me. So that would be what I would need to do if I was going to write this code as well. Yes, the algorithm works, great. Compile that, put it into the model, and then run that model. So I've got this running. So I've got this model that I've created. So now what I can do with it is go over here to web services. And this is predictive experiment. What I can then do is I can test it. So looking at my data here, what I can do is do this test preview. And it will then see how it can predict data that it doesn't know. So I'm going to go ahead and open this up. So again, this would be a good tool to start getting yourself familiar with the concepts so that you can do it itself. So what it is able to do if I entered the data myself, it's going to predict how well the data that I entered is able to guess if somebody is going to be making less than or more than $50,000. So I'm going to go ahead and enable some sample data because this is a lot of information for me to remember. So what we're looking at here is if somebody is 39, they work for the state government, they have a bachelor's degree, 13 years of education, they're never married, they're doing clerical stuff, they're not in a family, they're a white male, they had a capital gains of 2,174, they didn't lose any capital, and they were worked 40 hours a week, and they're born in the U.S., what's their likelihood based on this criteria is that they're making less than $50,000. So I'm going to go ahead and test that. And it says that that is indeed correct. and the probability of it that they're making less than $50,000 is 0.1. So I'm just basically scored it and determined that they are what my score was and whether I'm able to correctly guess this. So this gives you ability to test your data independently of what you have to do. Now, if I wanted to, what I can see for the input data,
You're putting the answer in the input data.
I could take it out.
But you use that to train a model.
I have trained my model already, and this is testing the deployed model.
Input data that already contain an answer.
This is data that I make up, so I can change any of this. So I can make this a female. So this is not data that's in there already. This is data that I'm making up, so that I can use to see that the model works. Given now, I don't know that the answer is correct when I don't know the answer, but I could do that with a data set that I know to see if it does it correctly. But I could also make it up and see how well it does for things that I don't know, which is my real world test of this anyway, because in the future, I'm going to test things that I don't know versus things that I do. Because that's generally the purpose of this. So will I know if this is 100% right if I didn't have the answer to the data to begin with? No. But if I can test it with stuff that I do know and then test it with I don't, that's the point of doing this kind of machine learning. Make sense? Okay. Because yeah, this is not canned data. So I can change whatever I want to and see if it makes a difference for my response. And I gotta have to guess if they're less than $50,000. Oops. You're right. It would probably give me an error. It tells me that I need to enter a number. Okay, where's the delete button here? It's smarter than to know that, so. So this says that they are not likely to, the scored probability of it, they're making less than 50 is very low, which means this is that I entered if they're less than 50 or not. I didn't leave it blank. If I'd left it blank, what they're basically saying is this person is, because this person, I changed it from male to female and I changed the capital gain, this person is likely to be making more than $50,000 based on what I've input here. Because of my probability of less than or equal to 50 is so low. So they're saying that, yeah, that's not right. So this is actually higher. So this is testing that particular concept. The other thing that I can do with this is I have the ability to, it'll create the code for me. So I can look at doing configuration for this and giving the input schema so that I can test this against other data sets. And it also has, where is that? It also has the ability so I can call this, where is it? Within, call my trained models from something else. So I could call this from within .NET as well. So it's a fully componentized module that you can do. So you can take this and you can run it in anything that you want. The other thing that this application also has is kind of implementation of Jupyter Notebooks. Microsoft is throwing Jupyter Notebooks everywhere now. It's in the latest version of Azure Data Studio, and it is in here as well. So if you wish to create a Jupyter Notebook in here, you can use that. And when I go ahead and do that, it doesn't I can use that in this experiment, or I can make it so that I pull it into another item. So let me go ahead and close this. So I can just say new and do notebooks, and I can open up, say, a blank R notebook or a Python notebook and start writing my code from within here. And it'll run it so that I can include that in part of my experiment as well. But if you are running on a laptop that you want to use a Jupyter Notebook for because you want to do R, but you don't want to do all that installation on your machine because they won't let you, you could also use this particular environment to just run Jupyter Notebooks and save them off to your machine should you wish to do so. For example, I've got some here, and I can take this and save this locally and run it locally should I want to do that, or just play around in a Jupyter notebook without having to install a bunch of things too. So it gives me a lot of flexibility. Oh, great. And that's not the one that I wanted to pull up. But does anybody have any questions about, what you might be able to do with this? Pull this one up. So I really encourage you to explore this tool if you're trying to get started, because it does offer a lot of different experiments. It offers a lot of places for you to go look at existing samples. And it also provides the ability to go ahead and pull things up. So I could pull up a new Jupyter notebook or download the one that I've got and be able to do that kind of testing. So does anybody else have any questions? All right. All right, so one of the things you can do if your results aren't very good is think about what you're trying to do and determine what you're trying to do if your data will help you do that. Look at preparing your data, understanding your data, look at what algorithms might be good for that. Start off with the ones that Microsoft has for doing your analysis. Evaluate the results and kind of keep on going until you're satisfied. In summary, if you're looking to do this practical stuff, you can do it with the right data sets. You can review your results pretty quickly if you're looking at it within Azure Machine Learning. And there's a number of different ways of analyzing it within Azure Machine Learning. And there's a lot of samples that you can use to show how you can move yourself along in this particular environment. So, does anybody have any other questions? No? If not, I wanted to basically do a shout out to these sponsors, because without their help, this wouldn't be possible. And I really appreciate the chance to talk to you today about Azure Machine Learning. Thank you.